So here students, here I come again with a new chapter, surface area and volumes. So today we will solve some important questions related to chapter surface area and volumes. We will solve some important basic questions and then slowly we will take on some important and more advanced level questions. So you bear with me and I will help you gain strength and build your concept from the most basic level to the most advanced level. So before that I will like to write some important formula which is related to this chapter. So after I will write the formula, then I will take on some questions based on that formula. So first of all, let's see which are the important formula which are going to be used in this chapter. So students, these are some important formula which is related to the curved surface area of different shapes. So you see that first line has written curved surface area of cone. So the curved surface area of cone is given by pi RL, where R is the radius of the base of the cone and L is the slant height of the cone. We will find out how to find the we will see how to find out the slant height of the cone with the help of the radius and the height of the cone. Next we have total surface area of cone. You all know the difference between curved surface area and total surface area. So the total surface area of cone is given by pi RL plus pi R square. Where this pi R square has been found because of the area of the base. Because the area of the base of the cone is circle, so we know that the area of the circle is given by pi R square. Next, here is surface area of sphere. This comes out to be 4 pi R square. Again, R is the radius of the sphere. Next, this is the curved surface area of hemisphere. We also I want to tell you that there is no such thing as curved surface area or total surface area. There is only surface area of the sphere. Next, we have curved surface area of hemisphere. This is going to be 2 pi R square. And at last, the total surface area of hemisphere, which is going to be 3 pi R square. So these are the very important formulas which you should must remember in order to solve any important questions related to surface areas. So now let's take on some basic questions one by one and help to understand the use of this formula. So student, this is another important question that I have written here, which is related to the surface area of cone. So in this question, it is given that a cloth is used to make a conical tent. Now we have to find the dimension of the cloth, out of which the width is given as 3 meter and the length of the cloth we have to find out. And it's also given that the height and the radius of the conical tent that we are going to make with the help of this cloth is given by 8 meter and 6 meter respectively. And it is also given in the note that there is some extra cloth which is needed for stitching purposes and that length is given by 20 centimeter. So how will you find the length of this cloth? So you see that since the conical tent is the tent is a conical shape, it means that we have to first find the surface area of the cone, which is the shape of a conical tent. Okay. So you see that here, as I have written in the previous slide, the formula for finding the surface area of the cone is given by pi RL. We will not use the concept of total surface area because we are not going to cover the base of the tent. We are only covering the outer surface, not the base. So here we will find only the lateral surface area of the cone. And we know that the lateral surface area of the cone, this formula is given by pi RL. Okay. So now we see that the radius of the cone is given as 6 meter. So it is very easy now. But we are not given the slant height. So how will you find the slant height of the cone? So we do this formula. See. This is a cone. This is called the slant height. It's given by L. This is called the height of the cone. It's given by H. And this is called the radius. So you see that this is the right circular cone. It means that this angle is equal to 90 degree. So we will use the Pythagoras theorem in order to find the value of L. You see that value of L comes out to be under root of R square plus H square. Now, since R and H are already given in the question, so we can easily find the value of the slant height. So first we will find the value of the slant height and then we will use the value of L in this formula to find out the lateral surface area of the cone. So this will be our first point. Suppose the lateral surface area of the cone comes out to be x centimeter square. Sorry, x meter square because the dimensions are given in meter. Now, since the area has been found out and here we are using the cloth which is the shape of a rectangle. The cloth that we are using, it is the shape of a rectangle whose length we have to find out. I have denoted it by y. and the width of the cloth is given as 3 meters. Okay, so we know that the total area of any rectangle is given by length into breadth. Okay, it means that the area of the rectangle is given by 3 into y, and this same area of cloth now has been used to make the conical tent. So it means that the length of the area of the rectangle will be same as the total surface area of the cone. Okay. So we see that in part 2, what we have to do? We have to just equate this area to this area, and from there we will find the value of y. So that will be our length of the cloth that will be used. It is also given that 20 centimeter is extra length. So the length that will be found out by this formula, you will add 20 centimeter to that value, and then we will get the final answer. So in this way this question will be solved. Let us move to the next question. So students, this is another question which is related to the surface area of hemisphere. So in this question we see that a hemispherical bowl is given whose inner diameter, it means that there are two types of diameters in a hemisphere, outer diameter and inner diameter. So the inner diameter is given by 10.5 centimeter. So in this question we have to find out that what will be the cost of plating tin on the inside of this hemispherical bowl if the rate is given by rupees 16 per 100 centimeter square. So we see that in order to find the total amount of tin which is used to plate the entire inner surface of this hemispherical bowl, that area will be called the curved surface area of this hemispherical bowl. It will be not included in the total surface area because we will not cover the top of the hemisphere with the tin. We will only cover the inside of this hemisphere. So you use this formula of lateral surface area or the curved surface area of hemisphere. So we know that the curved surface area of hemisphere, it is given by 2 pi r square. Now you see that since the diameter is given by 10.5 centimeter, so the radius will be given by 10.5 by 2. So we will use this formula that r is given by p by 2 is equal to 10.5 divided by 2, and we will use this value of r in this question, and then we will easily find out the curved surface area of the hemispherical bowl. Now since after we have found the curved surface area of this hemisphere, now at last we have to find out what will be the cost of tin which is used to plate the entire hemispherical bowl. Now we will make a table. In one column we will write cost, and in the other column we will write area. So in the first line we will write that what is given in the question, that is the cost of plating 100 centimeter square. Okay, this is all in centimeter square. We will write here only, so we don't have to write again and again. So for plating 100 centimeter square, the cost is given by, which is rupees 16. Now after we have found curved surface area of this hemisphere, suppose the answer comes out to be x centimeter square, so we will write here x, and we have to find this value. So this can be found easily by, suppose this is given by y. So y is equal to 16 into x divided by 100. So in this way we will find easily total cost for tin plating this hemispherical bowl only on the inside of this bowl. So this is an important application of the formula of hemisphere. So let us solve some more important questions in our next two slides. So student, this is another extension of that previous question that we have solved from the chapter hemisphere of curved surface area of the hemisphere. So the important part that has been added to the previous question is that in this question we have been given the thickness of the steel that has been used to make the hemispherical bowl. So the thickness of the steel is given by 0.25 centimeter. In addition to that, we have been given inner radius that is given by 5 centimeter. So in this question we have to find the outer curved surface area of the hemispherical bowl. So just we have to keep this thing in mind, that to find the outer curved surface area of the hemisphere, we have to find the total outer radius. This time we won't be finding the inner radius because it has been given to find the outer curved surface area of the hemisphere. So we will find first the outer radius of this hemispherical bowl. So the outer radius, it will be easily found out by adding two radius. What is that? First we have to find inner radius given already in the question, that is 5 centimeter, and we will add 0.25 centimeter, that is the thickness of the steel that has been used to make this hemispherical bowl. So we will add the thickness of the steel to the inner radius in order to find the total outer radius of the hemisphere. So outer radius will be given by 5 plus 0.25 and total answer comes out to be 5.25 centimeters. Okay, so this will be used in finding the outer curved surface area of the hemispherical bowl. So again, we will use the simple formula that we have been used in the previous questions also, that is the curved surface area, that is the not the curved surface area, the curved surface area of the hemispherical bowl is given by 2 pi r square. And we will use the value of r in this question in order to find the curved surface area. So only in order to explain the concept of 0.25 cm thickness, I have taken this question. Otherwise, this question is similar to the previous question only. So with this, let us move on to some more examples. So students, this is one last question which I have been taking from the surface area concept. So here it is given that a sphere has been enclosed by a right circular cylinder. So we have to find in these questions that what is the surface area of the sphere. Then we have to find the surface area, that is the curved surface area of the cylinder. And at last, we have to find the ratio between two. So you know that I have already mentioned in the formula that I have discussed in the first slide that the surface area of sphere is only the total surface area, or the curved surface area is the same for both, and it is given by 4 pi r square. So let us suppose that this is the radius r of the sphere. So we know that the surface area of the sphere is given by 4 pi r square. Okay, so this is only the 4 pi r square. Now since the value of r is not given in this question, so we will use this formula only as the answer to the first part. So the surface area of the sphere comes out to be 4 pi square, and we have taken this as equation 1. Now let's see how to find the curved surface area of the cylinder. So we know that the curved surface area of the cylinder is given by pi. What will the curved surface of the cylinder? The curved surface area of the cylinder is given by 2 pi r h. 2 pi r h. So we have learned in our previous classes, that is in class 8, that the curved surface area of the cylinder is given by 2 pi r h. Now let's see what is the radius. We see that the radius of the cylinder is same as that of the radius of the sphere. So we will use that radius only in solving this question. And what will be the height? We see that this is the height of the cylinder. Now if you observe this question very carefully, we see that the height of this cylinder is same as the diameter of the sphere, because this is also the diameter of the sphere. Okay, so in this question you can easily see, if you observe very carefully, that the total height of the cylinder is same as the diameter of the sphere. Okay, so since we know that diameter is twice of the radius, we do this formula here, 2 pi r, we will keep it as it is, and in place of height we will use diameter, and diameter is given by 2 times of radius, we will given by 2r. So it comes out to be 4 pi r square. Okay, so the curved surface area of the cylinder comes out to be 4 pi r square. And at last we have to find the ratio between them. You see that since these two equations are same, so the ratio comes out to be 1:1. Okay, so in this way we will solve this type of questions. So after solving 3 important and very important questions which have been asked in previous exams from the concept of surface area, let's move on to our next and very important concept, which is called the volume of the solids. So students, I have written some important formula which will be used in solving the important questions from the volumes chapter. So you see that the volume of the whole is given as 1/3 pi r square h. So you will use this concept in finding the important question when it will be asked in our questions. So r is the radius of the base of the cone, and height is the h is the height of the cone. Next, I have given the volume of the sphere. Its formula is given by 4/3 pi r cube. Again, r is the radius of the cone, and the volume of the hemisphere is given by 2/3 pi r cube. And we see very quickly, and we see that the volume of the hemisphere is just half the volume of the sphere. So we will just use these 3 formula in order to solve questions from the most basic level to the most advanced level. So let us take the questions one by one and solve it very quickly. So students, we have taken one important question with So students, I have come with a new question which is from the concept. So students, I come again with an important question from the chapter of volumes. So in this question is given that this is the heap of wheat, that is wheat grains are arranged in the form of a cone. So this heap of it has the shape of a cone, and the diameter of this heap of the brick, which is formed in the shape of a cone, the diameter is given by 10.5 meter and the height is given by 3 meter. So in this question we have to find out the total volume of the brick grains. So we see very easily that in this question we have to find that in order to find the volume of the conical shaped heap of it, we just have to use the formula that I've just discussed in our previous slide, that the volume of the conical shape is given by 1 by 3 pi r square inch. So R is already given because we know that the diameter of the base of the cone is 10.5. So we use that R is equal to d by 2 is given by 10.5 divided by 2, and height is already given as 3 meter. So just we have to put the values in this formula and we will get the volume of the heap of this heat grains. So in the second part here we have been asked that what is the total area of the canvas which is used to cover this entire heap of brick. So we have been asked to cover this entire heap of brick with a cloth or canvas, and we have to find the total area of this canvas. We see that in this question we have to find the top surface area of this conical shaped heap, because we are not concerned with the base of the, we will not put cloth in the under the heap of the brick, we just cover it from the sides. So we will see that we use this formula of top surface area of the cone, which we have discussed in our previous slides. This is given by pi r l. Now, since the radius of the cone is comes out to be 10.5 by 2, so it is already mentioned here. But if you want to find the length, that is the slant height, L, that is the slant height of this cone, again we use the formula that slant height is given by under root of r square plus h square. Since r is given by 10.5 divided by 2, and the value of h is already given in the question, so from this formula we will find L, and we put the value of L in the formula of top surface area of the cone in order to solve this question finally. So let's move on to our next question. Friends, this is another question related to the volume of the solid space, and we see that this question has been related to the celestial bodies Earth and Moon. So in the first part of this question it is given that the diameter of the Moon is 1/4 of the diameter of the Earth. So this is an important fact that is given in the question, and in the next part we have been asked what is the ratio of the volume of Earth to the volume of the Moon. So you know that the celestial bodies, be it Sun or Earth or Moon, they all have the shapes of spheres. So we use the formula for finding out the volume of the spheres in order to find the question answer. Okay. So we know that the volume of the sphere is given by 4 by 3 pi r cube. Now, first we have to find out the radius of the sphere, that is the radius of the Moon and the radius of the Earth. So in this formula we have given that the radius of the Moon is 1/4 of the diameter of the Moon is given by 1/4 of the diameter of the Earth. So now how will we write the diameter of the Moon? That we have to see. So diameter of the Moon is given by half of the radius of the Moon. It is given by half of the radius of the Moon. So I written diameter of the Moon as let's write more clearly now. We will use small alphabets for writing the radius, that is r of Moon divided by 2. Okay, so r by 2 is same as the diameter. Let's see. We know that d is equals to 2r. So we will use this picture. So there was a mistake in this part. Since diameter is 2 times of radius, so since diameter is 2 times of radius, so to replace the diameter of the Moon, we will write 2 times the radius of the Moon. Okay. And it is equals to 1/4 as it is. And diameter of the Earth again is given by 2 times the radius of the Earth. So from here we see that 2 and 2 gets cancelled out. So 4 times is given by radius of the Earth by radius of the Moon. Okay. So radius of the Earth is 4 times the radius of the Moon. So we will use this formula to find out the ratio of the volume of the Earth to the volume of the Moon. So let's move on to the next part. Let's write the formula for the volume of the Earth, given by volume of Earth 4 by 3 pi r of Earth cube, and if we divide it by the volume of the Moon, it is given by volume of the Moon also equal to 4 by 3 pi radius of the Moon whole cube. You see that 4 by 3 0.4 by 3 pi gets cancelled out, and this equation can be written as r by r mole divided by whole cube, because we know that since in the exponents chapter we have already learned that a cube upon b cube is equals to a by b whole cube. Okay. Now you see that r upon by r by mole is given by 4. So just use the value of r by r mole from here only. It is 4 times of 2. It comes out to be 4 point 16 and 16 point 64. So you see that volume of earth is 64 times volume of the moon. So this way we will solve this question. Now let us solve some more important questions. So this is another very basic question from the chapter which concerns both volume and surface area. So it will connect both these chapters. Now it is given that the volume of the sphere has to be found out, and the surface area of this sphere is divided 154 centimeters square. So students, you know that the surface area of the sphere, this is both the sphere, that is total surface area and cross surface area are both same for every sphere. So the surface area of the sphere, the formula is given by we write the formula for surface area of sphere. It is given by 4 pi r square. Okay. So since it is given 154, we will put the value of 154 here, and 4 into 22 by 7 into r square. So we have to find r square we have to find, and that value will be used in the value of the sphere. So r square is given by 154 into 7 divided by 4 into 22. Okay. So you see that 11 gets cancelled, 11 to 22, and 11 on the 11 for the 34. So it is going to 2 7 the 14. So answer is 49 by 4. So r comes out to be here under root of 49 by 4. X comes out to be 7 by 2 centimeters. So we use this value of r in order to find the volume of the sphere. Let's move to the second part of this question. So now let's come to the second part of this question. In the previous part we have found that the radius of the sphere is found to be 7 by 2 centimeter. So we use the value of the radius in order to find the volume of the sphere. So we know that the formula for finding out the volume of the sphere is given by 4 by 3 pi r cube. So this is the formula here, 4 by 3, value pi comes out to be 22 by 7, and the radius of the sphere is found to be 7 by 2. This is the formula here, 7 by 2 times 7 by 2 into 7 by 2. Let's cancel the important things here. So see that 7 7 is 49 into 11. So how will you multiply this here? 49 into 11 comes out to be 9 to the 4, 9 to the 4, 9 and 13 and 13. Answer to find 39 by 3. This is the volume of the sphere. Okay. So this was a very important easy question, but it was very useful because it connected both the concept of volume and the surface area. Now let us move to the next question. students, this is another important question from the concept of surface area and volumes. So here is the dome, and this dome has to be whitewashed from the inside. So in the first part it is given that the total cost of whitewashing from the inside comes out to be rupees 4989.60, and in the second part it is given the rate of the whitewashing. So the rate of whitewashing is given as rupees 20 per meter square. So in the first part of this question, they will ask to find out the inside surface area of the dome. So students, we know that there are two types of surface area for any, since this dome is in the form of hemisphere, so we know that there are two types of surface area, the total surface area and the lateral surface area. Since this dome has to, in this first part of the question we have to ask to find out the inside surface area. So we will use the formula of the curved surface area of the lateral surface area of the hemisphere. We won't be using the total surface area, because in the formula of total surface area we add the this long part, that is this part also, the base of the hemisphere. So since we are not whitewashing the base of the hemisphere, so we will be using the formula for the lateral surface area. So we know that the lateral surface area or the curved surface area of hemisphere is given by 2 pi r square. Okay. So this is the formula. So we see that for finding out the curved surface area of hemisphere, we have to find the radius and the things. But let's see what information we get from the question that is given. So in the question it is given that 1 meter square has the rate of whitewashing to be 20. Okay. So first we will prepare a table. So here we will write the cost, and here we will write area. Okay. So for whitewashing 1 meter square, the cost comes out to be rupees 20. So let's put this in meter square and this in rupees. So for whitewashing 1 meter square, rupees 20 is being charged by the constructor. Now since the total cost of the whitewashing comes out to be rupees 4989.60, then what will be the total area? So that area which will be found out by this table will be actually the total curved surface area of the hemisphere, which has been asked in the first part of this question. So we have to find this value only in order to find the inside surface area of the dome. We won't be using this formula because the radius of the dome will be not mentioned in this question. So let's review next. So we know that 20 times x, we just use the cross multiplication method. 20 times x is equals to 4989.60. So the value of x comes up to be 4989.60 divided by 20. So if this 0 comes here, this decimal puts here, and value comes out to be so this is the value of the total surface area. Okay. 249.48 meter square is the inside surface area of the dome. Now this was the first part. Now let us go to the second part and see what has been asked in the second part of this question. Now, in the second part of the question, it has been asked what will be the volume of the air inside this dome. So, if you observe the question very carefully, we can see that the air, total air which will be contained in this hemispherical dome is the same as the volume of the hemisphere, because the volume of the hemisphere contains all the volume of this inside of this hemisphere, and this is same as the volume of the air which will be contained in this hemispherical dome. So, if we find the total volume of this hemispherical dome, then that answer will be treated as same as that the volume of the air which will be contained in this hemispherical dome. So let's first find out the total volume of the hemisphere. So since in the previous question we have found the curved surface area of the hemisphere, and it came out to be 250 meters square. Now from this curved surface area, first we will find the radius of the hemispherical dome, and with the help of that radius we will solve the second part. So since we know that curved surface area of the hemisphere was given by 2 pi r square, so we will use 250 here left hand side, and we will write here 2 pi r square. So from here we will find the radius of the dome very easily, and then we will use the value of r and then we will put this value of r in the second part, because we know that since the volume of the hemisphere is given by 2 by 3 pi r cube. Okay. So just we have to put this value of r here, and we will get the value of d. So I am not solving this question. I have left this question for you to solve, because I mentioned the steps, and from there it is very easy. There is nothing, you will not face any difficulty in solving the question. So with this we came to the conclusion of this chapter. I hope you enjoyed today's class. I have tried to mention each and every concept related to this topic, and I hope you will solve any questions if you face this type of questions in your board level exams or any competitive exams with more confidence and a more solid approach. So if you like us to make more amazing content like this, please like, share and subscribe our YouTube channel Easy Maths for You. Till then, stay tuned.